We got 27 divided by 2. Now that's a straight up, fraction. And what we could do is try to break 27 down into prime numbers. And prime numbers, it breaks down into, what does it break down into? 27, 3 times 3 times 3 gives you 27. And that doesn't reduce anymore, right? If you're doing the prime factorization, right? Prime trees. So you could either express it like that as a number, 27 divided by 2, or you could write it as a mixed number, right? There would be an integer up front, and if it doesn't go in completely, you would have to write it as a fraction. And that's exactly what we're going to do, right? Now, while we're doing this, just imagine that the top, 27, was actually a polynomial, and the bottom was a polynomial as well, where the degree of the bottom polynomial is smaller than the degree of the top polynomial, right? Because that's, in that case, you can actually do the division, right? So what we're going to do is do long division for this to break this down, to break it down into a mixed number, right? We actually want to find out what 27 divided by 2 is. Now, you should know how to do this, but, in your mind right now, it's going to be 13 and a half, but we're going to go through long division and actually do it, okay? So the long division statement, the way you express it is the following. So the way you write it out is 2, and that's your division statement. That's not a root symbol, okay? That's divided, so 27 divided by 2. You read this sort of backwards. 27 divided by 2. Or 2, how many times does 2 go into 27? Now, we did a video of this in the first series, and it's quite simple. It's long division. It just takes a few steps to do. So what you're going to do is, and you're going to ask yourself, does that 2 go into the first number? In this case, it does. If it didn't, you would go on to the next number and see how many times it would go into the next number. So how many times does 2 go into 2? Well, that's just 1. So you put the 1 up top and multiply it out and put whatever the result is at the bottom. So what we got is 2 goes into 2 once. So 2 times 1 is 2. And you're going to subtract them. That's where the negative comes from. So 2 minus 2 is going to be 0. What we're going to do now is bring the 7 down. So how many times does 2 go into 7? Well, that's going to go 3 times, right? So you're going to put the 3 up top there, and you're going to multiply it out and put the result down here. So 3 times 2 is going to be 6. So 3 times 2 is going to be 6, and you're going to put the minus sign there because you're subtracting. So 7 minus 6 is going to be 1. Now, 2 doesn't go into 1. And what you could do, if you're looking for decimals, you could put a decimal after the 3 and then start adding zeros and continue from there, right? And if you did that, you would put a decimal after the 3, so 13 point, as soon as you add a decimal, you can borrow as many zeros as you want and put them back here, right? So what you're going to do, you're not going to put 5 or 6 zeros, you're going to start out with 1 0, right? So what you can do is turn the 1 into a 10, and 2 would go into 10 5 times. So after the decimal, you put a 5, and then when you did the subtracting out, you would get 0. So the answer would be 13 and a half, which is what 27 divided by 2 is, right? But we're not going to do that because we want to stay with fractions, especially with polynomials. We want to stay with fractions, okay? Now, 27 divided by 2, you can write, multiple ways. You could say 27 divided by 2 is equal to 13.5, right? Or 13 and a half. So what we got, you could write down 27 divided by 2 as 13.5, or you could write down 27 divided by 2 as 13 and a half, right? 13, so 27 divided by 2 would be 13 and 1 divided by 2, okay? So the way you could write it is 27 divided by 2 is equal to 13 plus 1 over 2, which is what we can derive from here, right? 27 divided by 2 is going to be 13 plus 1 divided by 2 by your denominator, right? Now, terminology-wise in mathematics, this guy's called the dividend, that guy's called the divisor, this guy's called the quotient, and 1 is called the remainder, and again, that guy's called the divisor, right? So what you have over here is 27 is your dividend, 2 is your divisor, 13 is your quotient, 1 is your remainder, okay? And this is the terminology that we want to get out of here. So you can write down this expression in the following form. So you can write this expression, 27 divided by 2 is equal to 13.5, as your dividend divided by your divisor is equal to your quotient plus your remainder divided by your divisor, right? Which is exactly what we had over here with the pink, right? 27 is your dividend, 2 is your divisor, 13 is your quotient, and 1 is your remainder. And this guy, because we don't like fractions, we can multiply both sides of the equation with the divisor, with the small d. Or you can think about it, the top guy, we can multiply by 2. And that will get rid of our fractions. And that's the form we're going to express our polynomials, okay? You can express your polynomials in this form as well, but we're going to express it in the other form, which is really called, this is also called the division statement, which we're going to look into a lot further. There's a lot of meaning here, okay? And we will talk about this, but keep this in mind. We're just going to move over and grab another wall and, expand on this concept.